We use identifiers all the time. Your phone number, your passport number, your email address. These are assigned identifiers. Someone, usually an authority, gives them to you, and if someone wants to check whether they're valid, they usually have to ask that authority. But not all identifiers work that way. Some identifiers are derived. That often means they're calculated directly from the thing they identify. In the digital world, this often means taking a file or a piece of content and running it through a cryptographic hash function. The result is a digest, a short, unique fingerprint of that content. Change even one character, and the digest changes completely. These are called content-addressed identifiers. Now, let's add another layer, cryptographic trust. On the internet, trust is often established using a pair of keys, one private, one public. A private key is used to sign something. A public key is used to verify it. If you want to check who signed something, you look up their public key and use it to verify a signature. And how do you look up that key? One common way is through a decentralized identifier, or DID. A DID is the identifier that lets a user resolve a DID document which holds or links important information, like the public keys associated with that identity. Now, here's where it gets interesting. If we combine these ideas, derived identifiers, DIDs, and cryptographic keys, we get something called a self-certifying identifier. This is a special kind of identifier that proves it belongs to a specific entity without needing an authority. How? Take the first entry of a DID document, its genesis, which includes the controller's public key. Now calculate a digest of that document. That digest becomes part of the DID itself. Because the digest includes the public key, you can't change the key without changing the identifier. If someone tries to claim that DID using a different key, the digest won't match, and everyone will know. DID WebVH and DID WebS both use these kinds of identifiers. In other words, the identifier certifies itself. It's tied to the cryptographic material at its core, and that makes it secure, verifiable, and tamper-evident, just the kind of identifier we need in a decentralized world.